I'm Mustafa Alhamdi. I have a PhD in heart abnormality detection. I'm here to presenting Innovative Physics Limited, which is a new company that taking its foot into the artificial intelligence world in the medical side, and specifically on the radiation section. If you go next, please. Okay, so in innovative physics, we are very interested in a variety of sections of medical applications, starting from the lung cancer detection, and also not just for lung cancer detection and detecting tumors and segmenting them as well and giving an indication of the sizes of each tumor. Now, one of our interests is, as well is belongs to the ability to detect CT scan images that are very clean, and that's why we are interested in the radiation part. We use gamma sources to build those CT scan images. Now, prostate cancer and bone cancers as well, other interests that we are working on, and it's under development that may be find its foot into the industry very soon. And clearly, as I'm the senior scientist within the organization, my PhDs belong to ECG and detecting heart problems. So we already have that system is really embedding into the company that we're trying to develop it even more to be a product prototype for the industry. So if we go next, please. So why we think that's really very important nowadays to include AI in the medical applications, mainly because of it's showing some promise. It's saving time for the doctors to do diagnosis instead of spending long hours looking at a couple of CT scans with the high resolutions. These AI models nowadays with the feature extraction methods can help a lot to pinpoint into region of interest for the doctors, not just time, but also accuracy. We, as human beings, we have the limitation of our eyesight. Well, machine learning can go deep down and extract features that may be not very easy to pinpoint by the eyes. And clearly, by saving time, saving a lot of queues for patients to get into treatment or diagnosis, we are saving a lot of money. And clearly, we don't need a doctor to run all these tools. The doctor will be assigned some sort of supervision into the final outcome of the models, but it's going to be an operator. So ease of use is one of the factors. Please, next. So what we're trying to do really is to take these information from the CT scans or the MRIs, and we're trying to extract where the regions that has abnormality compared to other sides of the brain or the lung or anything else. That's mainly what AI is trying. It's trying to do comparisons between benign regions and cancer regions and find the differences between those and make a model to learn those knowledge. So that's what we call it the creativity. And we can see in the graph how the features of benign and cancer should be split in the space, and that will be the main task of the AI. Many tools can do that: dimensionality rejection, feature extraction, classification, clustering, whatever we call them. The main point is to split the features of benign and cancer samples on different space. Next, please. Next, please. That's just to show how the features can be extracted. Next, please. Next, please. So our lung cancer model, as the CT scan is really big, it's not easy to train a single model with the full size of CT scan. It's almost impossible. So we came with a method that we are splitting the lung into small boxes, and these boxes will include cancer or not. And then we train a neural network system to be able to give the probability of that boxes including cancer or not. That will include a lot of optimization and neural network training. Next, please. So this is one of the examples that we feel is very interesting. After we trained our model for neural network, the outcome will be X, Y, and Z, wherever the lung or the tumor that we think that has some cancer, and also the dimensions of it. So we'll be able to give a dimension for the doctor or anybody else to use this tool to tell your tumor located at that place with that dimensionality and also with a probability of that's going to be a cancer or not. We think those AI tools, as clever as they're getting with time, they will still need a doctor opinion to make sure they are real a tumor or could be any other lung disease. Corona could achieve some sort of a tumors or similar shape to a lung cancer at some point within the lung. So we always give a probability or what we think it's really a very interested nodules for the doctor to look at, and that's why we call it nodule probability. Next, please. And that's it for me. I managed to have another 40 seconds just to talk about the innovative physics. I've managed to win a couple really of awards based on the work we're doing in the radiation and the medical side, that including the business and product innovation rewards for 2020, and also the South Coast Technical Company for our contribution in detecting neutrons in Fukushima in Japan, and also on the medical side. And thank you so much.